Welcome to class. Today, we're going to be talking about initial value problems. Well, here we have the definition for a first-order initial value problem. It is really just a first-order differential equation. I've written it in a slightly different format here to where I have u prime, or my first-order derivative, equals the rest of the stuff. There might be u's in there, there might be t's in there, all that good stuff. But the new idea here is this guy. We call this an initial condition. And it is what turns this into an initial value problem. Notice I've added the stipulation that my solution, u, has to obey this rule, that when I plug in t naught to the solution, that's just some t value, I get this u naught. That's just some output value, or u value. And that's what makes this an initial value problem. I think it'll be a little bit easier to understand, though, if we look at an example. So let's do that. Because I don't have an initial condition, this should be review. Let's give it a shot. I need to start from the left-hand side and show that I get the right-hand side. My solution, or the one I'm trying to verify anyway, is c e to the t. So the left-hand side is going to be the derivative of my solution. And what do you know? That's just itself. But hey, look at that. That's u. So I did get the right-hand side. Notice that my solution exists for all t values. Its derivative, which is itself, exists for all t values. And it does not matter which t value I pick, c e to the t is always equal to c e to the t. So not only is it a solution, it's a solution on all real numbers. But this video is about initial value problems. So what's the difference? Remember, initial value problems have an initial condition. So if I were to adapt this problem just a little bit, let's say I gave it the initial condition that u of 0 equals 3. Something a little bit magical happens. Do you notice that if c were 1, for example, if c were equal to 1, this is no longer a solution? In fact, the initial condition restricts me on which members of my family can be solutions. Let's take a look. I know that my solution has the form that u of t equals c e to the t. But when I plug in 0, I get c times e to the 0. Anything to the 0 power is just 1. So I just get c. But my initial condition tells me that that should equal 3. Well, look at that. Now I know the value of c. So I don't actually have a family of solutions anymore. There's a unique solution to my problem.